Hi students, now we will discuss about Maxwell's bridge. It is one of the AC bridge. This Maxwell bridge is used to determine the unknown value of inductance. Inductance. To determine the unknown value of inductance, this Maxwell bridge is used. And while coming to the circuit point of view, it is the bridge, Maxwell bridge. So initially I'm naming here. It is the first term. It is the first term. So I'm representing it is a capacitor. So I'm giving name as C1. Capacitor in the first term C1. Resistor R1. Resistor in the first term. It is the second term. The component is resistor. So I'm representing R2. Resistor R2. It is the third arm, and the component is resistor. So the resistor is the component and the arm is third arm. And I'm assuming these two are unknowns. So it is the resistor representing as Rx. It is the inductor L, and it is Lx. And the points as here it is A, B, and it is terminal C, and it is terminal D. And while coming to the construction point of view, between the terminals A and C, we're having the parallel combination of R1 and C1. Between the terminals A and D, we're having resistance R2. Between the terminals C and B, we're having resistance R3. Between the terminals B and D, we're having series combination of Rx and Lx. Between the terminals A and B, that means here, we're having AC source. AC source. Between the terminals C and D, we are having detector. Detector. This is the construction. Now we have to derive the expression for unknown value of inductance, Lx. This Lx we have to find. So first I'm writing the impedances what we're having in our arms. That means look at here. The first arm we're having here R1, C1 in parallel. So I'm writing here, we already discussed in parallel manner. When R and C are in parallel, then Y equal to 1 by R plus J omega C. We already discussed. R and C are in parallel, then Y equal to 1 by R plus J omega C. So here these two are in parallel. So it is in the first term. So Y1 from the figure, from bridge circuit, Y1 is equal to these two are in parallel. So 1 by R means here it is R1 plus J omega C1. 1 by R1 plus J omega C1. It is from the first term. And second arm only having resistance, so impedance, write it. Second arm na impedance at second arm Z2 is equal to resistor, can be represented as a resistor as it is R2. Coming to the third arm, Z3 impedance at third arm equal to only resistor, so R3. And coming to the fourth arm, that is Zx equal to, here these are in series, R and L are in series. And look at here, whenever R and L are in series, then Z equal to R plus J omega L. So R means here Rx plus J omega Lx. These are the impedances from the four arms. Now we know that bridge balancing condition in AC bridges. Bridge balancing condition in AC bridges is Z1 Z4 is equal to Z2 Z3. We already derived this. Z1 Z4 equal to Z2 Z3. Here actually Z4 fourth term is nothing but Zx. So I'm writing here as Z1 Zx equal to Z2 Z3 since Zx equal to Z4. Now look at here. Here I'm having Z1, but in my values I'm having Y1. So now I'm converting this Z1 into Y1. Z1 into Y1. So the relation between these two is Y1 equal to 1 by Z1. Now I'm converting my equation in terms of my required manner. So I'm writing this expression as Zx equal to Z2 Z3 by Z1. Here it in the 1 by Z1. 1 by Z1. That means 1 by Z1 equal to Y1 since. So here instead of this 1 by Z1 I am writing there Y1. Zx equal to Z2 Z3 Y1. That is the equation. Now I am substituting all these values, this one, this one, this one, this one in this equation. So Zx is nothing but Rx plus J omega Lx equal to Z2 is nothing but R2, Z3 is nothing but R3 into Y1 is nothing but 1 by R1 plus J omega C1. Now just multiply it internally. So Rx plus J omega Lx equal to R2 R3 into 1 by R1. R2 R3 by R1 plus this one into this one. J omega C1 into R2 R3. Now compare real parts. Real parts and imaginary parts we have to compare. Here the real parts are this one at this side, RHS side, this one. I'm equating these two. So by comparing that, Rx equal to R2 R3 by R1 is Rx. And now compare imaginary parts. Compare imaginary. Imaginary means those who are having J term, that is called as imaginary. At this side, J omega Lx equal to J omega C1 R2 R3. This one cancel. Then Lx equal to, look at here, C1 R2 R3. It is Lx. Like this, we can find the values of inductance by using Maxwell's bridge. And here we can also calculate the quality factor. Quality factor Q. This Maxwell bridge is limited for a quality factor of 1 to 10 only. 1 to 10 only, this Maxwell bridge. So here the quality factor is Q equal to omega Lx by Rx. That equal to omega into Lx is this one, C1 R2 R3 by Rx means this one. So R2, R3 in the denominator it will becomes R1. This one cancel. Then Q equal to omega C1 R1. It is the quality factor for Maxwell's bridge. Like this, we can find unknown value of inductance by using Maxwell's bridge.